So here we have statistics. Again, help me out for the videos. If there's ever a red light on here, that means I have it on mute, and it makes the videos awful because you can't hear anything. So let me know if that happens. Hopefully it's recording. Usually there's a little red light at the bottom. It looks like it is. Okay, here we go. Statistics. Science of data sounds so exciting. So it is analyzing data. And if you're a pure mathematician who likes algebra and things like that, sometimes you find statistics doesn't have as much mathematical meat as some of the other areas of math, like algebra and stuff like that. However, it is one of the most important skills to have, because no matter what subject area you're looking at, or even in your everyday stuff, you run into statistics all the time. You pull out a newspaper, they have statistics in there. Sometimes the statistics that they have make sense. Sometimes you'll realize with your mathematical abilities, yeah, it doesn't quite make sense what they're saying, or there's a mistake there. Or you might, because you're highly mathematically literate, you might realize that, ooh, they're trying to use statistics here to influence me in a certain way. So those are kind of things where the study of statistics is really, really important. Univariate, which fancy word, uni for one, variate comes from variable, one variable. We're looking at statistics right now that involves one variable. So if we're looking at all the shoe sizes in this class, that's the one variable that we're looking at. There is two types of statistics. Either stuff that is descriptive, which is called qualitative, or quantitative, which you can put a number to. And in quantitative data, which is the number stuff, which is what we're going to be studying, you either have continuous or discrete values. So an example of continuous is someone's height. Every single height is possible. You can't all of a sudden, it's not like you are bulging and start to shake and all of a sudden jump up a whole inch, right? You grow all of those heights in between before you get to that next inch. And so we say that that data is continuous. Stuff that's discrete is stuff that goes up certain things, like your shoe sizes. You're like, oh, I'm really an 8 7/8 shoe size. Could you find that for me? No. They're going to give you a size 9 and say that's good enough. Whoops, skipped too many there. Here we go. And in statistics, the term includes all members of a defined group. What word is going to be under there? Yes, population. When you only use a part of that population, that's called a sample. So here's a little diagram. Population is the entire thing that you're studying. It's not the entire thing always, because, for example, if we wanted to know what students in this school thought, we're not going to, the population doesn't include all students ages 13 to 18 all over the place. It's just in this school. And a sample might be this class. Now, we want to often look at random samples, because if you look at a random sample where everybody has the same chance of being asked, that's where you're going to have, hopefully, that sample is the same as the population. Now, depending on how big your sample is, you're going to get a better representation of your population. And so a lot of statistics looks at how big of a sample do we need to be sure that it represents what the population says. So frequency table is an easy way to look at data and look for patterns. So for example, in this, here's the first question. Scientist was counting fish caught in each day for 30 days straight. There are the results of those 30 days. Now, when the data is presented like that, it doesn't tell us very much. It's just a bunch of numbers. So if we can organize that and figure out how many and then look at its frequency, it may tell us more important information and be easier. So what you would do is you count, how many 10s do you guys see? 3. So if you were going through and counting them along and making a tally. Now, I'm going to give you all of this data quickly here because from a mathematical perspective, counting how many 16s you see and spending the next 5 minutes doing this wouldn't necessarily be the best use of class time. Now I've also drawn here a bar chart. Now a bar chart has bars. Those bars often have spaces in between. We're going to also look at histograms. Histograms don't have spaces in between. Sometimes you'll see bar charts where they actually have them touching, but generally a bar chart does have a single bar with spaces in between. I did a little break in my graph here. As far as my graph goes, I haven't labeled it enough yet. I've got my numbers there, 10, 11, 12, 13, 14. I did a little break in there so that my scale still follows nicely. So I need to label that this side here is my frequency, which in our case is the number of days that that happened. And if we look at, what this down here, this was the number of fish caught.